Good morning, everyone. We will get started here in a few minutes. Let people get settled in. It's not quite 10 o'clock. Okay, it is now 10 o'clock. I'm going to give just a few more seconds. People are sort of trickling in here, but we want to get started on time because Armando has a lot to tell you. Just a few more seconds. All right, let's get going. My name is Katie and I work at the Lighting Design Lab, and welcome to today's presentation about network lighting controls projects in schools. We often abbreviate it NLC, so you'll see that a lot if you're not used to it. Just some house cleaning stuff. You're all going to be on mute, but we've got the chat feature enabled over in the menu. I think it should be on the right-hand side of your screen if you haven't used GoToWebinar. Type any questions you want. They'll be submitted to me, and Armando can answer those for you. About every 10 minutes or so, he's got a pause to address those, and a little poll too. So please participate in those. It's just clicking a button and a little interaction to keep the webinar moving. At the end, there is a survey though. So as soon as you close out, there'll be a very short survey to take to let us know how we are doing. And we are recording this. If you don't get to hear it all, or if you want to go back and listen to something that Armando says, we'll have that up on our website in the next few days, along with a slide deck of the presentation. And there is our general email address if you think of any questions or have anything you want to tell us after the presentation. We are part of Seattle City Light. So all of the employees of Lighting Design Lab are City Light employees. And it is City Light's commitment to its customers that allows us really to do the work that we do. And this presentation in particular has a sponsor, the Better Bricks program through NIA helped sponsor this program. They have funded it as part of the Regional Luminaire Level Lighting Controls Initiative, the LLC, if you've heard that acronym. And if you're interested in learning more about that and the resources that Better Bricks and NIA has for you, go ahead and visit them. I think we have the hyperlink enabled when you get the presentation later off of our website. Can't click it now. Or use Google. Just really quick, in case you're not familiar with the Lighting Design Lab, we've got three sort of distinct but intertwined groups of customers. And there are many of you represented today. Some trade allies, design allies, and end-use customers can all benefit from the resources that we have to give you. And besides the education and training that you're taking part in today, we do participate in technology evaluation if you would like our help with that. We have lots of tools and resources available online. We unfortunately have had to like many places, shut our doors. So the picture you see in the background, we can't access right now. But we also do some information aggregation, like from Lightfair is a really fun one that we do, and just kind of try to be a hub of all the information that you need for lighting controls, smart buildings, all of that. And without further ado, let me present you Armando Berdiel.
Thank you very much, Katie, for the introduction, going through our things. Thank you, everybody, for being here with us early December. We're going to be talking about how to jumpstart network lighting control projects in schools. A little background about me: have a computer science and engineering management background, schooling, then jumped myself into the world of residential and commercial lighting controls. I learned, interestingly enough, lighting controls before I learned about fixtures, lamps, and the sort. So have that more so controls focused background. But then I wore pretty much every trade ally hat on a small implementer firm in the Northeast of the United States. But very excited now working in the lab, helping disseminate information about connected lighting and helping market transformation. So very excited again to talk about these topics. And today, our learning objectives are going to be to understand and apply network lighting control hardware and features, to gain knowledge and how to ask the right questions when you're implementing network lighting controls in schools, how to leverage utility and regional resources, and how to navigate those financial and operational conversations that happen in these projects. Before we get started, I wanted to poll the audience a little bit, see who is with us. It'll give me a better idea of how to curtail some of what we're going to be talking about today. So please, if you can answer the poll on your screen. Which most closely defines you? And Katie, can you confirm? Oh yes, people are voting, so good. Just wanted to make sure that the poll is actually working. I see more than half of the people have voted, so that's great. Getting a few more last votes coming in. All right, I think I'm going to go ahead and close the poll. So you see good amount of designers, government, municipal utility people, and a couple of others. Should be a diverse crowd. So good, let's go ahead and get started. I think we're back into the presentation. So let's start with the why are we here? We're here for some good old learning and having those smiles focus on the learning, and not just students, but staff and everybody that works in K through 12 educational facilities. We are here to improve the built environment, the quality of light and life in these buildings first and foremost. And yes, we are also looking at maintenance and operational savings, as well as a couple of non-energy benefits and automation. But when it comes down to it, it's down to the people. We want to improve the space for the people in it. How are we going to be doing this? From the learning objectives, and you see on the screen, hey, we're going to leverage those utility incentives and resources. We're going to look to implement quality lighting with less glare, automatic reductions, and all that good stuff. Establishing that support structure with the implementers, with the utility, with the subject matter experts, and ultimately, yes, reducing the energy bill. And lastly, what are we going to do, or what are we talking about? We are talking about implementing network lighting controls in schools. We have to admit that the odds have been stacked against network lighting controls. Say 10-ish, 15-ish years ago, people know about, playing almost Morse code on sensor switches to be able to program them to whatever the timing and sensitivity settings you want it to be. People still have painful nightmares of having to go into the roof hundreds of times to change dip switches on sensors in the ceiling. And even when wireless technologies came out, there were still some issues and some funk with the connections and devices losing communication. And lastly, when you have your daylight sensors, a good amount of designers and implementers are all too familiar with the Dixie cups taking over those sensors because the lights were not acting the way the tenants wanted them to act, so they just covered them up or disabled them in some way, shape, or form. So very true that, hey, NLCs may have some bad connotations in the mind of some decision makers and stakeholders in K through 12 educational facilities. But today the story is a little different. Yes, there is a long way to go for network lighting controls to be the most seamless they can be, but it is a lot smoother today than in the past. And it is in no short part because of a lot of the features, as well as the control reliance and reliability that the systems are now really getting. Now the manufacturers have had a good amount of time to play with emerging technologies. These systems are becoming all the more reliable, and a lot of the features are becoming much more attractive than just energy savings. That applies as well to wireless network lighting control systems, which is the bread and butter that we will be discussing today, where these wireless protocols have gotten a lot more reliable and a lot more complex and flexible now than in the past. And also, if I can plug a little bit, Lighting Design Lab is going to be doing a deep dive on wireless protocols and IT for 2021. So stay tuned for some good research and some good dissemination coming from this. Ultimately, it is still a money conversation, and savings, the operational savings that we get from network lighting controls is ultimately very important. The image you see here is from the DLC, the Design Lights Consortium. They're a qualifying body for lighting products. And you know, they released a report in, I believe, 2017, 2018, stating that, hey, with aggressive utility support, subject matter expertise, the savings prospect for controls is a lot larger as we learn how to optimize systems and reduce light when we don't need it. So not just, if you see from the image, not only do we get solid amount of our savings from outdoor, indoor, switching from legacy sources to LEDs, but controls can be part of that savings as well, in a more equal part, not just marginal savings. And we also want to look at the emerging technologies that are going to happen, because these emerging technologies, these features are going to be what really drives controls implementations. Sadly, the class today, we're not necessarily going to get into all of the technologies that network lighting controls can have. But yes, today we're going to be looking at code compliance, savings, how can we leverage rebates, implement controls. But in the future, we're really going to be looking at asset tracking, circadian lighting and tuning, space utilization. So hey, lighting controls can be the infrastructure for these technologies. So installing them sooner rather than later will be a worthwhile investment. So right now, I wanted to start a little bit with some terminology, the base terms of lighting, the control strategies, so we can be in the same page of what we're going to be discussing. So tomato, some semantics. You may have heard of network lighting controls, advanced lighting controls, smart lighting controls. It's all, to an extent, the same thing. Terminology, advanced lighting controls, it's almost a synonym for network lighting controls. The real reason many people had not adopted the term networked in lighting controls was because of a connotation on the IT end that, hey, every single device was going to need an IP address or something along those lines that was going to go in the client's network. And not necessarily the case. When we say networked in the lighting controls world, we more so talk about the ability for the systems to communicate in themselves. These are systems and devices that will have one or two-way communication among themselves, and they'll communicate with facility professionals via, app-based commissioning tools, computers, or remotes, XYZ. So that's when we talk about networked. Again, not IP address related, but more so communications enabled. Katie just mentioned it, Luminaire level lighting controls, and we're going to go into a deep dive in a little bit. But for now, I just wanted to note these are a subset strategy of network lighting controls. And when we think about your smart fixture, that is what Luminaire level lighting control systems are. Again, we're going to get into this in a little bit. But hey, when you get lighting controls or just controls in the lighting world, these are your generic umbrella term for network lighting controls, smart lighting controls, as well as your standalone controls. These are just devices that are more analog. That hey, they're just hardwires. Think about your hardwire sensor that is wired into your fixtures in a restroom. That's like a standalone control that does not communicate to any type of configuration tool. So outside of those semantics, we're going to be talking about, just controls terminology as well as some of the strategies. At the end of the section, we'll leave for questions. But if you have any questions, you can also ask them in the chat, and Katie will let me know so we can discuss. But we can start with a zone. What is a zone in lighting? It is the fundamental indivisible unit of control. It's important to understand how to optimize, the zones in a space. You can have many fixtures be part of one single zone, and the idea is that zone will have the group of fixtures operate together. If you raise that zone, all the fixtures in that zone are going to go up. If you lower that zone, all the fixtures in that zone are gonna dim down. So again, you cannot subdivide a zone once it's been set unless you reprogram it from a configuration tool that usually only facility personnel can have access to. And if you see, for example, how the zones are laid out in this drawing from a classroom, usually the electrical contractor or the lighting drawings are going to have fixtures designated by their zones, and that is how controls need to then be able to operate all those fixtures in one zone together. So they need to be either wired or the fixtures need to be grouped in some sort of programming. A zone can almost mean that you have one or more of these load controllers. So load controllers are devices that wire to fixtures. And if you see, like, some of these or almost all of these have the nipples to be hooked up to a junction box that's going to go in the ceiling very near the fixtures that it controls, and it's going to be wiring via both line voltage, and if it's got any dimming protocols, those wires as well. These load controllers can come in flavors from 1 amp that usually go on only one fixture, all the way to 20 amps, where one load controller can control, a whole open office worth of fixtures. And usually they'll have 0 to 10 volt options for dimming, although some architectural systems can also have forward phase and reverse phase dimming protocol control. Zone controllers or wall stations. There's two general types of wall stations. Ones that control a single zone. So basically, if you have one group of lights, these wall stations will just control that one group of lights, and they're going to be specialized to that one group. These wall stations can dim, they can just be on off. Some of these wall stations may even have sensors in them in itself. The other more complex set of wall stations are what you call your scene or preset wall stations. These wall stations will control more than one zone. So you may have different flavors, like the one on the top right has no raise and lower buttons, but each of these buttons will be able to operate and change multiple zones of light to give you that special look. That's when you have, for example, if you can read here, hey, morning scene, your afternoon scene, your evening scenes, and scenes are again multiple zones or a zone set in a specific intensity meaning a percentage of light from 0 to 100 of how bright or dim that zone is going to be. And scene just encompass many zones together. Ideally, and as you see on the top right wall station, the ideal thing to do with wall stations is to engrave them to give an idea of what that scene is going to be. However, today we see a lot of wall stations not different from this, that they are unengraved. And hey, it's a problem. We're gonna discuss that still in a little bit later on the presentation. But it's so much better to have an engraved wall station when you want to know what each button can do. So high-end trim, now we're talking about actual control strategies. And high-end trim, also known as task tuning, those two terms are pretty much synonymous. What it does is puts a ceiling on the maximum brightness that your fixtures can get to. So for long story short, when people specify fixtures for a space, they'll usually be conservative and get a lumen package that's usually brighter than the needs for a room are. And that's correctly done in the sense that you don't know if that room is going to have darker roofs or walls than originally planned, or you don't know that some fixtures may be even decommissioned. So you need a brighter fixture or a fixture with a higher lumen package. And sometimes it's not needed, but it's better to have it if it's ever needed in a space. So what HighEnd Trim can do is ensure that, hey, if you don't need an excess of light, you know what your recommended foot candles are, you know what the light levels need to be in your space. And if the fixtures in a space are brighter than this, HighEnd Trim, again, is that ceiling that caps the max brightness. So you don't need that excess light. It reduces glare. It ensures that the fixtures run at less heat, so extends the life of the fixture. And ultimately, it does save energy because your fixture is not as bright or is not consuming as much energy as it could. So HighEnd Trim, very key strategy to implement. And the best way to implement HighEnd Trim or task tuning is by going into the space, looking at what foot candle level you're going to need in the space, then adjusting your HighEnd Trim to ensure that you go a little bit above your foot candles at 100%. So occupancy and vacancy, everyone's familiar with the sensors. And again, occupancy is a function of automatically turning on lights when a person enters a space and automatically turning them off if the sensors detect no one in the space for a set amount of time. The difference with vacancy is that you would need to turn on the lights from another, like manually via time clock or another way. Vacancy sensors only turn the light off when they detect that no one is in the room. And there's a ton of flavors of sensors where you can mount them in the ceiling, in corners, hallways. Some will have what they call coverage, different patterns of coverage. And these are usually beams that sensors shoot. And you can have, a circular coverage pattern. You can have a more thrown coverage pattern. We'll get into this a little bit when we talk about how to implement controls in different K through 12 spaces. But just note that the more important part about sensors is to think about coverage. For example, you see the bottom right image right here where, hey, we're entering a small office and you have a sensor right next to the door. However, because of the bookcase, the sensor does never sees the person that's sitting in the desk. So what will happen there, because that coverage is blocked, that person's lights are going to turn off on them, and all they'll need to do is that famous dance or wave for the lights to turn on. There's two major or main flavors of sensors. There's more, but these are passive infrared and ultrasonic. Passive infrared, they work through line of sight. They detect heat signals for people, so they'll need line of sight in order to work. And just because they're infrared, they can be wireless and be battery operated. On the other hand, the ultrasonic sensors, they do not need line of sight to work. They work like a bat, or our fellow Lego Batman here. They send and receive sound waves to detect if there are people moving in this space. However, they require constant power to send those ultrasonic sound waves. Thus, they cannot be battery operated. They're going to need to be wired to line voltage in order to get power. There are also dual tech sensors that can do both passive infrared and ultrasonic technology. When it comes to schools, think about a simple use case, a restroom. You have a lot of stalls in the restrooms that may not let a passive infrared sensor, get that line of sight to someone in a room, in a stall. But an ultrasonic sensor would detect someone if they're slightly moving in a stall and not turn off lights. Daylight harvesting, why is it really important? We can direct our eyes to the bottom image. Hey, you know what? If you know the lighting levels you need to have in a space, hey, in your work plane, you need to have 30-foot candles, great. And daylight, gets you 80% of the way there. Then you only need to spend, 20% of your electric light to get to the foot candles you require. So that's what we talk about daylight harvesting. Again, reduces glare, saves energy, and a strong way to commission daylight is to pair it with your motion sensors. So when someone enters a space, that occupancy sensor automatically turns on the lights, but not to a set level. That sensor will turn on the lights to the appropriate daylight level for that room to ensure that you have, number one, uniform lighting. Number two, you have the required foot candles or light level in your work surface. And again, extends the life of the systems and the lamps in it as well. So let's discuss time clock programming a little bit. Uh, Again, you can by both a specific time or through sunset or sunrise or sometime above sunset and sunrise, you can have lights turn on, turn off, or go to specific levels. Uh, a very powerful feature that's emerging with time clock programming is controlling occupancy sensor behavior. Depending on the time of day, or again, sunset and sunrise, you can change if your sensors could be, vacancy, occupancy, or what's better, you can do what's called the high-low application where, hey, from school hours, I want your hallway sensors to, when the hallway is occupied, I want the lights to go to 80 or 90%, like a good bright level. However, when there is no one in the hallway, I don't want the lights to turn off. I just want lights to go to like a 50% or a 25% light level, enough for safety, and when kids go out, it's not going to be pitch black on your hallways. However, outside of school hours, I want that light to go off when there's no one in the hallway. So that's a good way that time clock programming and occupancy sensors can work together. Load shed and demand response. So if I backtrack a little bit and talk more again about utilities, utilities have a finite amount of electricity and power they can give all their territory buildings and customers. So think even now in the winter, think of all these large buildings are pumping out their heat, their HVAC. It is possible then that the grid, the territory utilities grid, is reaching a maximum capacity because all their commercial and residential customers are just turning up their heat a lot. And there is a risk, eventually a risk of a brownout or a blackout if everyone's using, maxing out the energy usage. So utilities will ask their customers to turn down some of their load. Network lighting controls can do this automatically to get or receive a signal from a utility and automatically trim all their dimmable lights, 30% or more or less. Switch lights that can go off, and that's a walkthrough when you're commissioning your network lighting control system. You can go space by space if you want to and see what light level can be shed in an event that a utility asks the school to lower the lights. Conversely, if you don't have network lighting controls and you don't have a central way to lower the load of the building, you'll have a lot of facility technicians just running around turning off breakers when they can. So again, network lighting controls help this process, automate this process a lot. So it's not just about the energy savings, but labor and maintenance savings as well. Nice image on how you compound some of the major network lighting control strategies. HighEnd Trim being that cap of that ceiling from not allowing lights to go above a maximum level. You have your occupancy periods where, hey, if people are not in a space, light's gonna turn off. You have daylight harvesting where the more daylight available there is, the less electric light you need. And hey, you can even have people in offices or other spaces given personal control. People by themselves will not want, for example, the lights to be bright all day. They'll be dimming the light accordingly depending on what they prefer and their visual adaptation prefers for them as well. And obviously you have, hey, how demand response may work where, hey, after a certain amount of load that you cannot cross, the utility is going to ask you to reduce your load usage. So I've been talking about savings a lot, just so we're on the same page where it comes to savings. Where do savings come from? The way we're looking at energy these days is power and time, right? And we're measuring power by kilowatts, so 1,000 watts per hour times hours. And that unit of measurement that we use is the kilowatt hours, right? So for example, I grabbed this again from last year, this year. Every kilowatt hours for a medium general service in the downtown network for Seattle City Light is going to be paying around 9 cents and change per kilowatt hour. So the more you can reduce that wattage and the more you can reduce those hours, the less your rate will be. When you're in a school building and you convert from legacy light sources to LEDs, you're automatically reducing the wattage by about 15 to 75%. Adding NLC or LLC systems, you can definitely reduce the operating hours because sensors will turn light off when you don't need it, as well as time clocks and personal control and many of the strategies that we just discussed. And it'll also reduce wattage because you think high-end trim is basically cutting the wattage, putting a ceiling on the wattage that a fixture can have. I've been mentioning luminaire level lighting controls a lot, and they are again a subset of network lighting controls that are defined by having, number one, individual addressability. Each fixture can be addressed individually, can be one zone. They have integrated occupancy and daylight sensors in the fixture itself. The fixture by itself will be able to continuously dim, down to like 5%, 1% or below, but it can just continuously dim. It's not going to be bi-level switching inside of a board or a fixture. And that it's networkable. And again, when we say networkable, it is not that it's a one IP address per fixture, but it can communicate with devices in its system, as well as communicate with facility personnel through a communications configuration tool, app-based, remote, what have you. Again, visually, NLC systems, you'll have your load controller, separate daylight sensor, separate occupancy sensor. LLC will have those sensors as well as the full dimming built into the fixture itself. A great way to think about it is one-to-many and one-to-one. You can have one load controller, one sensor for many fixtures, or you have one sensors, one load controllers in every single fixture in one fixture. And again, you have less components, so you have those labor savings, easier to configure because you only have one device rather than many that you need to pair, discover, program together. And some of the better features for luminaire level lighting controls is that future expandability or future proofing space, because the space can always be remodeled, it can change, and you don't need to go in the ceiling to rewire your zones as you're changing a space. It can just be pre-programmed in an app based tool, be it your, in your phone, iPad, computer. They just need to be reprogrammed if the space changes. And as a bonus, LLC devices automatically meet code. To get a bit more specific as to how LLC meets code, this is from the 2018 Washington State as well as the Seattle Code. The language is the same on both, where, hey, when it comes to lighting controls, if you have LLC luminaire that's independently configured, so we're talking about that in the individual addressability, and has, monitors occupant activity, that's your occupancy sensors, monitors ambient light, that's your daylight sensor integrated, and can be easily reconfigured, so that's networkable. So if for lighting controls, if you have LLC devices, that is all you need. You don't need to have a lot of separate devices for lighting controls in order to meet code. So just a little bit of an example of how luminaire level lighting controls systems can work in an actual application. Consider an open office where at 7 a.m. you'll have your first people walking in, but the lights will be on at a background level, say 20%. Again, just for that safety where someone's coming in potentially from the outside, where at 7 a.m. in wintertime, the lights are very, the outside's still very dim. There's not that bright. So in order to not get that flash of brightness when you walk in, lights can be on at a background level. And at 9 a.m. where you have some people already in their desk working, but some people still coming in, you'll have the lights at a higher level when people are working in their desk, in their area, and you'll still have lights at a background level when they are unoccupied. As people walk out, the same thing happens. People that are still in their desk will have higher light levels. People that are leaving will have the lower light levels. And this is all done automatically due to LLC technology. A lot of these fixtures are just pre-programmed to just act this way. And the space will not turn off until the last person leaves. That's when the lights will go off, when the last person leaves. Not sure if you're as familiar on LLC technology, but I wanted to get your guys' take on LLC. So from these four options, hey, are they, your go-to solution? You create awareness to clients, but leave it up to their decision. If it's not in a spec, don't really touch it. You're looking at it to see if LLC technology can be more quote unquote mainstream before you address it, or hey, not looking to use it. I'm sticking to zone-based NLC strategies. So we have a couple of people that are voting already. Thank you for those that are participating. Ooh, I see very polarized responses. That's pretty cool. All right, and I'm going to be closing the poll. So I like it. Good amount of a spread where, hey, it's either a go-to solution. Half of us, hey, we educate clients on this, which is great. Awareness is great. Even if it does not get selected on a project, building that awareness is always good. But leave it to their decision. And I have a couple that are a couple of voters is, hey, waiting for this to be more mainstream, or deciding not to use it for the time being, rather sticking to the zone-based applications. For those who are still with me right now, do we have any questions, Katie?
We do not currently have any questions. Just a reminder, type in whenever you feel like it, and we will address it when Armando has a pause.
Awesome, thank you. Moving on. So a couple of tips that before we get these projects started. Always good to understand, hey, what are my nearby regional resources? And hey, being part of City Light, I wanted to shout out City Light's energy advisors. They are always available for home and commercial questions. They can provide project specific support, or connect you to someone that definitely can. Uh, Best to know in your region, hey, definitely always connect to your utility, and I'll emphasize this point later, and connect to some subject matter experts that are also, trained to help, and are serving as resources for, be it questions, consults, project-based type of questions. Always ask for help. Never shame. Only good things can come out of it. Before starting these projects, I always consider a lighting audit that good first impression to start a project. Uh, Again, lighting audit, you'll have a technician pretty much audit or count every fixture, lamp, control in a building, or in the spaces of a building that are going to be worked on, renovated, in order to get those energy calculations so you can benchmark energy consumption. So understanding, hey, what does my building have today? Oh no, I have T12s in my back of house. I have a ton of fluorescent T8 still everywhere, and all the controls that I have are wired sensors to relays that just turn on and off. Lighting audits can let you know what you have, and usually you can do this in a spreadsheet. There are specific softwares that you can do a lighting audit on, and the real power of it is that you can make proposed solutions from benchmarking what you have. You can select, potential LED lamps, or you can select potential network lighting controls from your audit results, and evaluate different solutions from different manufacturers, and that's a very powerful thing. Important to note when you're looking at lighting audits is that not just looking at the energy consumption of a system, you also want to understand that if you have a lot of fluorescent or older legacy light sources, you'll have a good amount of savings from lamp and lamps, ballasts, as well as the labor that it would take to replace them. So important to note. And always, you can try to estimate utility incentives in audits as well, if you know what your utility program is and what accounts for it. So very powerful tool to have a lighting audit done right. Interesting to note, as you go about a lighting project, a lot of construction contractors typically upsell to the best system or the next best hardware, but you'll notice electrical contractors typically downsell. They talk about value engineering to try to remove hardware features at the last minute to reduce the upfront costs. You want to help clients mitigate that sticker shock, and electrical contractors sometimes want, in order to meet a budget or to make it more attractive, or even the implementers themselves will value engineer network lighting controls. They'll go, your T-LED route with some basic standalone controls and sensors, if anything. But again, everything that you may remove up front, be it features and hardware, ultimately is a loss after the system is implemented. Because what gets removed can usually improve the life of the system, provide those non-energy benefits that can really improve the quality of life of the tenants in a space. True value engineering should add to the upfront cost, again, to get systems and products that can be incentivized by utilities, or can give you a longer lifetime of the system. So again, the story should never be about the upfront cost, but about the life of the system, and we're gonna expand on that a little bit later. As early as possible when you're considering a lighting project, especially a NLC, network lighting control project, get IT involved. Like any other smart device, they can be a gateway to hacks from outside forces, hacks or whatever the case may be. The lighting world is getting hit to cybersecurity, and we spoke about the DLC earlier. They're even putting cybersecurity in what we call their QPL, their qualified products list. Side note on the DLC, if you go to their website, designlights.org, they'll have a downloadable version of their network lighting control QPL, qualified products list. And they have a web interface, but I like to download their spreadsheet. It keeps getting updated, but it talks about all of the features that these systems are qualified for, tested for, even including that cybersecurity feature that we were just talking about. And the good part about this list is, if you see this show, it's supposed to say show, SHOW, you can look at all the different systems, and if you expand these buttons, it'll tell you how each system approaches cybersecurity. What standards are they meeting? Are they meeting that UL 2900 that has to do with logins and passwords, or are they meeting any other standards that DLC is testing for? They get a good tool to look at, especially when you're shopping for potential solutions. You can show or hide any of the details for how the systems approach, even LLC control strategies and such, and you can see how each system approaches the capabilities. Before starting these projects, code requirements are also very important. What's the light power density? How many watts per square foot am I allowed to have in different building types, or how many watts per square foot are you allowed to have on space types and actual spaces inside of a building? There's different ways of doing the calculations, and I'm not going to get into detail with codes, but I am going to mention Lighting Design Lab is going to put together a 2018 code update delivery very early next year, January, February, for those interested in what updates from the 2015 to 2018 code that City Council is about to vote on in Seattle. Stay tuned for those deliveries. But again, understanding how much wattage you can use, understanding how to implement the different types of lighting controls if you're not pursuing that LLC route is going to be very important to get your certificate of occupancy, or keeping your certificate of occupancy, as well as being good with the utility incentive, because they're going to need for you to meet or exceed code. Before starting these projects, it is also great to understand the different implementers in your region. As you're looking for potential NLC system solutions, your decision should not only be based on the system hardware and features themselves. You also need to have a good relationship with the subject matter experts in your region, the people that are going to implement this. for manufacturers of these systems, again, they have that good global knowledge and technical advisory. They have their ear to the ground on the latest and greatest of the technology for connected lighting. But the territory reps, because most manufacturers sell these systems through a territory rep, they'll have that local know-how, coordination, and know how to better work in that specific territory. So that relationship is great. And a lot of the implementers will have procedural or technical efficiencies that can be that advantage that you need. For example, some manufacturers can if you have your sequence of operation documents ready, if you have your design intent ready, they can pre-commission your devices and package them depending, oh, all of the devices going into classroom 1 are going to go in this box, classroom 2, their own box, pre-commission. So again, a lot of procedural efficiencies you can take advantage of if you, again, do your research with the different implementers. Just like partnering with your utilities. Utilities, they want to see more NLC systems implemented. The reason that you're here in this class is a show of that. Utilities want to implement efficiency controls. They know that these controls also improve the quality of life and light in a space. But again, utilities will assist not only by providing those rebates and incentives, but they'll also provide project-specific support in order to ensure that these projects can move along and be a technical service or customer service. So really plug into your utility before or as you're embarking into one of these projects. One of the great things that they're doing is that they are right-sizing incentives. They are working on what they call estimated, or they call it a range or pre-existing values of when you are implementing different NLC or LLC technologies in different spaces. They'll estimate the savings and ultimately give you a better incentive depending on how you implement NLC or LLC technologies on a workbook and on spaces. Lately, the right size incentive or a premium incentive is $50 to $75, depending on the utility, on be it luminaire level lighting controls or specialty network lighting control applications. If you're curious as to how to get that $50 a fixture incentive for Scale City Light, you need to select a system that's in the DLC's, NLC's, QPL. That's a 9-letter acronym right there. You need to prove that you have programmed HighEnd Trim or task tuning, occupancy, and daylight harvesting in a space that has enough, that has a correct size windows or fenestrations for it. You need to have at least 2 zones per 300 square foot, unless you have more because the space requires more. Before the install of the systems, you need to show the utility a sequence of operations, and we'll discuss what those are later, but basically you can communicate design intent per space, as well as a floor plan that ideally has fixtures or controls in the plan itself. After the install, you'll need the as-built documents for the utility and obviously to conduct a site visit. What they will not allow is TLEDs to be incentivized, as well as fixtures under 20 watts. Although if HighEnd Trim moves a fixture under 20 watts, you have what they call a prorated $50 incentive. That percentage, you're under 20 watts, it's going to be that percentage that you're going to have under that $50. Quick question, just making sure that we're all awake and trucking along here. Can we please select all the benefits of a lighting audit? So only select benefits that a lighting audit can provide. There are some that are not. I want to see, hey, if you are picking up what those are. So if everyone can vote, hey, select all the benefits of a lighting audit. You can benchmark your energy consumption. They help calculate and plan for various solutions. Can lighting audit help communicate the design intent? Pre-populate a workbook. I appreciate you guys. Good. The majority of people are voting by now. All right, I'm gonna close the voting. and share. I think everybody pretty much got got the answers that I was looking for. It's a tougher one. It's a tougher case to make that it's going to communicate design intent, the lighting audit. But if you have a type of audit where you're proving or you're looking at tying potential solutions, those potential solutions can definitely communicate the design intent. And it is a different type of audit that would have prevented Enron's rise and fall. So it's a good call. All right, let's get back to it. Any questions by any chance? So on so far.
No questions. You're doing so well at explaining everything, I think. I appreciate
I like it.
the Enron thing. That was very funny to me.
Different type of audit.
Yes.
Awesome. All right, let's talk a little bit of light and health. And I understand, hey, K through 12 may not do 101, so consider it, hey, your third period, light and health. It is a topic that, hey, research is still ongoing of how the light wavelengths affect the human body. But even though, again, research is ongoing, what the main point that I'm going to want to communicate across is that, hey, there may be, or evidence is looking like there's a good amount of health benefits to changing the circadian uh, lighting in a space that's going to, benefit people as they go through their day for different things. We associate the warmer yellows with relaxing and turning down energy, with suppressing melatonin, with melatonin secretion. And the cool blues, you associate those with your higher energy environments, more concentration. And again, there is a lot of research going there, but as the research goes on, as there are best practices and trends that are revealed, the good news is lighting controls can adjust and adapt. So if you have a network lighting control system that can control lights in a space, especially fixtures that are tunable white fixtures, those are the ones that can change that color temperature. Depending on the best practices of the day, NLC systems can adapt and program and reprogram how you can have the proper illumination in a space. The important part on tunable white systems is to change your circadian entrainment. And this circadian entrainment is you can consider it a period of how your internal biological clock is entrained by recurring exogenous signals, light being a key part of it, such that the human body's endocrine and behavioral rhythms will be synchronized to those environmental cues. Again, lighting being a huge part of this. And again, a lot of research ongoing. Colleague Sean talks about the lighting hypocritical oath, where, hey, first do no harm and don't necessarily say, yes, this is going to help you in this way. No, the idea is to say research is ongoing. There are a good amount of observations that point at good things happening when people train their systems appropriately. And there are some agreed upon variables: intensity distribution, SPD, spectral power distribution, duration, dose, timing, and photobiological history that affect your circadian entrainment when it comes to lighting. So when we talk about intensity, this variable that affects your circadian entrainment is ultimately how much light is incident on the eye, how much light actually is reaching you. And we talk about a lot about foot candles on surfaces and work levels, but where we talk about intensity, we are typically looking at vertical foot candles to an extent, be it if you're standing or if you're sitting. So for example, if you're looking at the woman on the right-hand side of this painting, this space is not lit enough for her to have the correct light intensity that can help her circadian entrainment. Distribution, that talks about what angle the light is coming from. And the more impactful angles for light when it comes to circadian entrainment are what they call 90 degrees from the nadir and higher. nadir being 0 degrees or the floor because the zenith is the top, so nadir always being, the bottom 0. So more impactful lighting angles are above these 90 degrees of the nadir. So if you think about task lights that just point down and you're gonna get that indirect light, that is not as impactful as the illumination you get from above. That's why the original circadian entrainment is just from the sun, because that light comes from above. When we talk about spectral power distribution and how we manipulate those color temperatures, as well as obviously the SPD, what wavelengths are actually, for lack of a better word, hitting your body, hitting your eyes? A recent discovery of a photoreceptor that's non-visual is leading researchers to see that also that non-visible light affects your circadian entrainment. And again, the way you can control your spectral power distribution also does affect your cycle, your circadian entrainment, your circadian rhythm and stimulus. And as more research comes along, we may even discover more photoreceptors that do different things. But as we do this in the lighting industry, again, the common theme is network lighting controls can always be pre-programmed to get that correct concoction or pairing of all these variables together to get to improve your quality of life and your circadian entrainment. When we talk about duration and dose, it's, hey, at what light, what's the intensity from 0 to 100%? What's that angle? What's the color temperature? So all those variables together hitting you at one time, what is that dosage? How long are you going to be under that specific light level and color temperature and intensity? So that's when we talk about dosage. As well as the timing. When are you resetting your circadian cycle? And by resetting, you usually reset in the morning where there's no light, because it'd be at nighttime, or your lights in your house are off. And then when morning comes, or when you first open your eyes, there's a lot of light, because if you're going from darkness to like a good amount of light, that's when your circadian entrainment or circadian rhythm is going to get reset. When we talk about workers, or specifically evening workers, hey, they may even get their circadian entrainment like later in the afternoon or evening, and this may not be the best way to go about it. But for students, that they'll have that daytime shift, if you want to call it, in a school. Starting schools, typically 8 a.m. through 3 p.m. And even now in winter, where 8 a.m. is not as bright as it can be, having the correct levels when students get into school that, hey, match the outside as students are coming in, and then get gradually brighter during the day in order to ensure that they reset their circadian cycle and can go on and not necessarily be night owls, in the sense of, if some research can lead to see that if you're not timing your circadian cycle correctly, or you're having irregular levels of light throughout the day, or not enough light during the day, it may lead you to be more awake at night, get less sleep, and ultimately pay less attention during the day, or be less concentrating during the day when you're going to school. Last variable that I wanted to discuss is this photobiological history. So that's basically, over time, what is the patterns of light exposure during the day? Because let's say, hey, if you never have enough light during the day and have a lot of light at night, and you continue this pattern for a long time, there are adverse health implications, or such as what the research is telling us. And ultimately, again, that intensity, the distribution, the angle, the SPD, the spectral power distribution, all can be controlled with network lighting controls. And they can be programmed and reprogrammed to meet whatever the best practices our research leads us to believe are. I want to discuss a case study that the Department of Energy, along with their research arm, the Pacific Northwest National Laboratory, conducted on 3 classrooms in a school, where they wanted to evaluate pretty much the, hey, how does a tunable white system affect the student energy level, their behavior, how are they feeling? The students had to answer this simple question pretty much every day when they were under different light levels. So what they actually found in this study was that, hey, dimming was a primary benefit rather than the color temperature tunability. It will definitely helped, but dimming helped teachers set different cues for the students. Like, hey, like we're going on to the next activity, lower lights, raise lights, things along those lines. So they saw it as a great benefit to cue students for different activities. And still, the color tunability helped, but the benefit was seen as more secondary. There was definitely a lot of energy savings because they upgraded from fluorescent to LED, and their fluorescent control system only had a bi-level switching. That means you can turn your lights off to 50% if you see the gray, or turn them full on. The LED with the LED lights, they had obviously full dimmability and lighting controls, so they could dim and set different light levels. That's the blue bars in the space here. And ultimately, hey, the upgrade improved the working conditions for the staff and the performance of the students. So it's a good case study. It's linked here whenever we provide you guys, or you get these handouts on our website. You can check the links, or you can, again, as Katie said, Google. And I think I made the point enough, so I'm not going to beat a dead horse. Whatever the research is coming to tell us what best practices are, how to implement the color tunability to affect positively your circadian entrainment, lighting controls can adapt to whatever those needs may be. So quick check. What are those variables that affect circadian entrainment? We discussed a bit. I put some in there that are not. I want to see if we can vote the ones that are actual circadian entrainment variables and those that are not. Getting a few seconds for people to be voting. Thank you, all those that are voting. Gonna leave it for a few more seconds. All right, I'm gonna share the poll here. Thank you for the votes. The one I was gonna say is not a variable, is the CRI. That's more so how does the light ensure that the colors are rendered correctly and to the truest forms, but not necessarily a variable on the circadian entrainment concoction. So moving on here, I see that we don't have questions. No, we do not. So good, trudging along. Again, don't be shy. Anything you'd want to ask, we can answer live or we can take it offline. We are here for you. We're going to talk about some specific space types and implementations in school settings. Then on a lighter note, if you do have a moment and are a fan of the South Park show, they have an episode called IntelliLink, where they actually implement a smart building system in their school, and they do capture the more embarrassing parts of our industry. So good one to check out about IntelliLink. But talking about some spaces that will require, or what I call, hey, low hanging fruits. Stairwells, corridors, hallways, and garages. Code reads that, hey, we need to reduce light by more than half or more than 50%, by 50% or more, I guess, if a space is vacant for 15 minutes or 30 minutes for garages, or hey, whatever code can tell us. But again, automatically reduce light when the space is vacant by 50% or more. And again, restore light to a full or more than 50% intensity when someone enters the space. So a nice example when we're talking about stairwells, see the bottom right in an NLC approach is, hey, having, corner mount sensor for a couple of lights in a specific level. Important note about commissioning stairwells and hallways for that matter, just stairwells. It's important, for example, to not just light the floor that you're on. It's important to light, at the very least, the floor above you as well as the floor below you in a stairwell for safety, ensuring that, hey, you can come into the floor, and if you go up the stairs or down the stairs and it's dark, that could be a safety hazard. And again, you can have LLC stairwell fixtures, but they'll also have to be grouped in a way that if they detect occupancy, the levels above and below also respond to that and turn on. You can definitely have an entire stairwell light up if one of the floors is detects occupancy, but it does spend a bit more energy. When we look at corridors, we want to implement sensors that have a very long beam. There are some that have narrower, but even 1,500 feet beam that will be able to cover those long corridors. And they'll be able to tell a load controller to tell fixtures, hey, reduce to 50%, or hey, we see someone in the hallway, let's turn the lights on to some bright level. LLC applications, when you have hallways or corridors that have L shapes or different shapes, they provide a nice benefit where, someone opens this door, even the light over here will be able to turn on because of the communication from all the other LLC fixtures. Also very easy to do with NLC approaches, but you'll require more than one sensor placement in an L-shaped corridor. Still talking about low-hanging fruit, we can talk about restrooms, especially single-stall restrooms. I have the question where, like, hey, what's the difference between these two? This essentially with this look, those are the ultrasonic sensors, and these openings are where the sound waves or the sonar waves are being sent out of. The sensor that looks like this on the bottom, they have a square, that's the passive infrared sensor. So again, this one is good for, hey, is there going to be line of sight to the people in the space? And this one is going to be good for where there's no line of sight to the people in the space. In a bathroom that has multiple stalls, you can have those, again, ceiling sensors, be it the infrared or other sensors in the general area that are ultrasonic for the people that that are going to be in the stalls. And the question, hey, how can this implementation, how can this application be better? It will be better by separating the vanity mirror zone into its own zone, giving it its own load controller, and leaving the fixtures above the stalls and a separate zone unto themselves as well. What about emergency lighting? Emergency in the past, where lighting was on 24 hours on a constant hot circuit, and that's no longer allowed in code or in most cases, and is obviously wasting energy that does not need to be wasted. Image here for the Spokane Public Library, having these awesome floor-to-ceiling windows, there is no reason that this section, that's the emergency section in this long linear light, should be on. Nowadays, emergency fixtures can be controlled alongside normal fixtures. They can dim up and down, respond to sensors. It does require a bit more wiring know-how, or having what they call UL 924 load controllers or UL 924 LLC fixtures. But the idea is, with emergency lighting nowadays, during normal power operation, hey, the emergency lights act the exact same as normal, and the only difference is when power goes off, these emergency fixtures will just go to full on. Once power is restored, the idea is that the load controllers will recall the last level both normal and emergency fixtures were at, and put them together at that same level they were before lights went out. Some spaces that are, hey, we call them the middle hanging fruit. If you want to see my amazing Photoshop skills here, but hey, you can have private offices have very nice designs with your NLC application. That's your load controller for the space, occupancy sensors, and if there's windows, daylight sensors. But again, these three devices in an LLC design will all be part of that fixture. And if you look at this here, hey, you can have receptacle control in your office or in different spaces of your school as well. I haven't talked about receptacle control, but it's becoming a lot more prevalent in code. And from the discussions that I'm hearing on code is, hey, it's going to be looked at a bit more, enforced a bit more to have this receptacle control to cover what we call phantom loads, be it printers or microwaves that you don't want to necessarily need to leave them on overnight. You can turn on the power to them when people are in the space and turn off power to them again overnight, further saving energy in the building. Again, open office is not as different, just the square footage is larger, where you can have more sensors to ensure that you have coverage in an entire area. But ultimately, again, a lot less hardware and a lot less wiring external devices in an LLC application. What really remains is the wall stations, be it NLC or LLC, you'll still need wall stations if you want manual control of the light in the space. And I mentioned sequence of operations. Hey, a quick example is, and I'm not going to go through it, but it's as simple as a narrative of what is going to happen in a specific space. Break rooms, I wanted to just introduce the concept of, hey, you can have different types of sensors. Before we saw the round ceiling sensor, you can have corner sensors. Earlier we saw the hallway sensor that had the long 1,500-foot beam. But when we talk about other spaces such as the atrium, they're a lot tougher. These are going to need a bit more thinking in the sense that, hey, there are more architectural architainment concepts to think about. It's going to be more about the pleasance of a space. And ultimately, hey, you want to ensure that you have your zones separated out and know what each zone of light can do. You want to have scene wall stations that can control multiple zones into a specific scene, something that's welcoming to parents, something that's reduced light levels when the areas are not in operations, so on and so forth. Classrooms are one of these spaces that are a bit more complex because there's very many different ways you can implement lighting in a classroom. Again, ideal classrooms will have multiple zones of lighting that you can, again, as we saw from the case study, PNL case study earlier, you can dim lights up and down to respond to certain cues for different activities. NLC can also change color tunability in a classroom if the fixtures have that type of capability. But again, no different than the other spaces where you can have your distinct daylight sensor, occupancy mounted sensors, multiple load controllers. With LLC designs, all that is built into the fixtures. Even the linear fixtures can have the luminaire level lighting control qualities, those integrated occupancy daylight sensors, fully dimmable and networkable. When a classroom has many zones, it's always good to look at, number one, the plan alongside a sequence of operations that will tell you how that space is going to be controlled, because that sequence of operation or similar documents can communicate that design intent for a space. And here obviously is an example where classroom was using the majority linear fixtures. And it's usually good to have indirect fixtures and not have light, the lamp source hit the eyes of the students directly. That's going to cause
Hi, everyone. You are not the only one frozen. I'm also frozen. Armando, if you can hear me. Oh, I can see you now, and you are back. I cannot
Uh,
hear you. Oh,
is it back again? Katie,
I
can you
can
hear me
hear.
well?
Yep, I can hear you. Can you hear me?
Yep, I think we're all good.
Okay. So,
May have been a network issue.
yep, we're about 2 minutes. Lost you for about that long, 2 to 3 minutes.
All right. Well, thank you for that. I apologize for the loss of a signal. I'll keep it going from this page, commissioning versus startup, where startup is when lighting control devices first come online and you're programming, hey, you're going to be operating this way, or this occupancy sensor is going to affect these zones of lighting. When you are first programming a system, that's called startup. Commissioning is a process that takes a longer period of time. It includes that startup for sure, but also it requires even a third-party commissioning professional to certify the commissioning and the programming in a space. There's documentation that occurs during commissioning. And it also includes optimization. After a system is running for a period of time, it is customary for commissioning agents to go back, be it 6 months, be it a year, be it more than that, and optimize the system, be more aggressive with reducing light, uh, depending on the available foot candles you need to perform your tasks and activities. Oftentimes overlooked and forgotten, but extremely important, is to commission the occupants, especially your tenants, especially your teachers, the educational staff, administration, facilities. If you do a lighting project, it'd be remiss to not let them know what to expect and how to better interact with their lighting systems. Especially because sometimes a lot of installations don't have helpful engraving, or don't even let you know, hey, what's going to be zone 1, zone 2, zone 3. Sometimes they'll get interfaces where there may not be a lot of description as to how it's going on. So commissioning the occupants to let them know, hey, what to expect, and even engraving and having this is a game controller, but the idea is to engrave or have a guide as to how the different wall stations are going to work in a space for tenants to really know what they need. I wanted to see if there were questions, but all I saw is hey, I can't hear you, but I hear that I'm back, so I appreciate that note. So wanted to talk a little bit about the cost implications of projects in an angle that we go away from that upfront cost conversation, and we really want to think about the life of a system. So, the National Institute of Buildings did a study, 30-year study, where they noticed that, hey, the design, the construction, the rent, the overhead and maintenance costs had very little cost in comparison to everything under the HR of that building. It was an office building, and people noted that the cost year over year, month over month, from personnel, salaries, benefits, and everything was a lot more costly than the actual, building in itself after the 30 years. So that leads us to the 1-9-90% rule of how buildings not necessarily just use energy, but have their energy bill laid out. Uh, for buildings, 1% of the budget, 1% of your building budget is going to go to what you call energy and resources. This is, from your lights, HVAC, energy, water, waste, and how you use those resources. So 1% of your budget per square foot is spent on these energy and resources. Your paper, recycling. 9% of your building budget per square foot is going to be on the actual space use, your efficiency of your space use, and the layout that reflect your workflow. and offer an optimum environment for individual tasks. Hey, is it easy to walk from my desk to the conference room? Is it easy to walk from my desk to the bathroom? Is the office connected? Your layout, 9% of the building budget per square foot is going to go to that. 90% of your budget per square foot is going to go to employee wellness, productivity, student performance, staff and administration's performance. So that improvement to the acoustic and visual comfort to ensure that people, are in their preferred environment to work and perform at a higher level. That's where 90% of that budget for building square footage goes. And if we even want to take that a little bit further, to revenue and opportunities, that's when we're talking about some of those non-energy benefits, even including your tunable white systems, including space utilization, asset tracking capabilities that unfortunately are not part of this course, but those non-energy benefits that network lighting controls can serve as an infrastructure for, and not to mention the data that NLC systems gather. Nowadays, NLC systems are set to gather not just energy measurement data, but a lot of performance data about itself to, number one, be able to parse that information and suggest optimization improvements, but also be able to feed in two-way communications to larger building management systems. And again, crunching that data about how a building is run can always help optimize it. And that's where we talk about when we say revenue, cost savings, and opportunities. A lot of times school projects get delayed or stopped because of budget. And then it's important to discuss the cost of waiting. What happens when you wait too long to implement, be it LED or network lighting control systems in schools? It is very possible that utility funding runs out because utilities have a set and a finite amount of dollars to offer in rebates and incentives. You continue to overspend on energy because especially if you have legacy light sources, fluorescent, metal halide, incandescent, you continue to overspend onto that energy because you're not moving to LEDs. And even if your school or your K through 12 facility has LEDs, they can be on for a longer period of time that they're needed. They're not gonna go. It's possible they're not gonna turn off. In many spaces, don't have sensors, time clocks, and they're not gonna benefit from the high-end trim application in itself. So you continue to overspend on energy, as well as human capital, because legacy light sources, ballast lamps, they burn out a lot quicker than LEDs do. So you're spending, money for technicians to go, change the light bulb in a sense. And also your equipment, legacy equipment is when it near that end of life cycle where a lot of the devices may start failing, a lot of the lamps are gonna, continue burning out. So there is a true cost of waiting to implement projects. Oftentimes, when we're talking about budget and these projects, people want to know, hey, how long will it take for the system to pay for itself? It's an efficiency or it's an energy investment, right? So when is this energy investment going to pay for itself? When we talk about that, we usually talk about what we call the simple payback calculation. In its simplest terms, it's, hey, if I spend $100 today and I get $40 per year, let's say in savings, how long will it take until I repay my initial investment? So after 1 year, that's 40. After 2 years, it's 80. After 3 years, it's 120. But we know that at the middle of that year, so 2.5 years, it's when my initial investment was going to be covered. That's what we look at simple payback. When we expand it a little bit into lighting projects, that initial investment is definitely the cost of materials, labor, and whatever services the implementers and subject matter experts are going to include with your project. From the initial investment, you can always subtract any rebates from your utility, and that's going to be your total project cost. From that, you divide your energy savings per year, as well as, hey, what you save from not having to replace all your lamps, ballast, and sending your technicians to do this. So those are your real savings, and that's how you can calculate your simple payback. It is a relatively easy and quick calculation to arrive at, but it does not tell the whole story because it only focuses on, number one, the upfront cost and how quickly are you going to cover the upfront cost. Another calculation that can be more impactful is what they call the life cycle analysis or the life cycle cost. This in itself is a more difficult calculation to arrive at, and you have to include elements from all the initial cost, the delivery, installation, commissioning. Then once the system's in place, what are those savings that are actually realized? And then over time, how can we optimize these savings? Obviously, there's going to still be operational costs even when you implement a new NLC system, so that has to come in effect to the calculation. And all the calculations for the life of the system continue to run until you either decommission or remove the system from its place. It's a more difficult calculation to arrive to, but you can include and if you're very creative, include an objective monetary terms, all those features and benefits that your lighting system can provide, such as again your non-energy benefits. And a good way to capture those in a life cycle analysis is, hey, consider asset tracking. How much are you going to save on asset tracking by turning on the feature in your lighting system versus going on to a different vendor that simply does asset tracking, installing their infrastructure, paying for their software and services. So it pays to leverage your lighting system as an infrastructure to these added capabilities and not having to go to another vendor, another third party, and more overhead for your facility professionals. So that's good always to include, again, in your calculations as much as possible. Again, huge spreadsheet, but we're looking at a simplified 10-year, very simplified 10-year cost for a lighting system upgrade. So hey, just to tell that story about that simple payback, imagine a lighting system costs $65,000 a year, and hey, the rebate comes in at about $15,000. So your actual cost for implementing the system is your $50,000. Then we look at, hey, what happens with my energy and maintenance savings over time? They're going to be increasing, but year over year, and we're using a 10-year life cycle of a system, even though today NLC systems can last well beyond 10, 20 plus years. But it's always good to tell the story in financial metrics that are important to the educational facility, K through 12, be it the net present values, when we're going to do simple payback, what's the return on investment, where this is a longer class, we would get into the actual calculations. But the idea is to be able to tell this story that, hey, after I spend $50,000 on a new NLC system, year over year, what are the savings that I'm getting from that, and how slowly and surely it tackles that initial investment. And here we see that between years 3 and 4 is when the investment was paid back, and everything that happens after those savings from the new system are all profit for the school. When there are budget constraints, there is a new pricing model that's emerging as well. They call it, you can hear about it as lighting as a service or energy efficiency as a service. And it takes up a pretty much a subscription model where there's going to be the implementer is going to pay for the system, the commissioning, the installation, and even the maintenance. That, number one, ensures that the customer, be it the school, will always be cash flow positive. So what happens when the implementer pays for everything, pays for the installation? They also implement energy metering. They are going to see that difference between, hey, if you did not implement a new system, you were going to spend energy at these higher levels. But because you implemented this system, you're going to spend energy at lower levels. And those implementers are going to be paid by that difference between the higher energy bill and what your energy bill is going to be because you implemented a system. So that difference is how these implementers are going to get paid. That still ensures that you are cash flow positive, and you have your new system, you're going to spend less energy. You can take advantage of those non-energy benefits, and eventually, you're going to pay off the system, and all of those savings can be yours to keep. Seattle City Light has a pilot program that has a version of this energy efficiency as a service model where, again, and they're looking for projects. It's on the system. So if you're interested, please contact the energy advisors at Seattle City Light. But it's very similar to how I was just explaining it, where, hey, before a retrofit project happens, you paid this level of an energy bill. After an implementer implements an NLC system and LEDs in your space, you're going to pay less, obviously, because there is an efficiency project implemented. So what happens in the Seattle City Light pilot program is that the customer stays bill neutral. Even though you're consuming less energy, you're still paying the same bill as if you had not installed that project. And that difference is going to be used to pay for the system until the system is paid off. And then you'll be able to keep both the new system as well as the savings once it's paid off. Another resource I wanted to bring up is the Trade Ally Network Northwest Field Guide. So the TAN, Trade Ally Network Northwest, great solid organization that helps, again, also catalyze market transformation for connected lighting through training and boots on the ground work. They developed a field guide for both HVAC and lighting, and pretty solid resource. And it has a section that says, hey, if they say, you say, and it goes over different scenarios of budget objections as well as potential solutions and what conversations can be had for people that are focusing on that upfront cost a little too much. I think it's going to be the last poll for the day. Hey, what are good strategies to combat a budget shortage conversation? So when someone wants to implement a project, but they mention they may not have the budget to implement it, what are good strategies to discuss to help this conversation along? Do we want to discuss the cost of waiting, discuss non-energy benefits, value engineer the project to meet budget, wait for the next budget cycle? So if you guys vote, hey, what are good solutions when a customer or a K through 12 building says, hey, we don't have the budget to implement this system, so maybe come back when we do? What can be good suggestions or good conversations to navigate that? All right, closing in a few seconds. All right, thank you guys for voting. See, the majority do like that discussion on the cost of waiting. They want to discuss, hey, what are those non-energy benefits that you are missing out of because you're not implementing this? Hey, we can suggest energy efficiency as a service pricing models. That's good. And I'm glad that, hey, we're not looking to wait for the next budget cycle or look to value engineer. I appreciate that. Moving along here. See if there's any questions, and it seems that there are not, so that is awesome. Last section for us today here. Hey, keep it simple in the communication. How can we be concise, direct, and impactful in communication when it comes to network lighting controls? Well, we are very familiar with fixture schedules as part of the drawing construction documents, but if you don't see a control schedule that also pairs with that fixture schedule, it's good to ask for it to be done, because you'll know exactly the hardware and the hardware specifics that you're going to be using in your project. We've talked a little bit about a sequence of operations, and they come in a few flavors. For example, on top right, you see a simpler sequence of operation that just talks about space types. as well as the different control strategies and capabilities that you can have. And you can just have a simple matrix where you check off what space type is going to have what feature. There are more complex sequence of operations that include, full narratives. They'll even be paired to a drawing and say, hey, zones X to X are going to operate in this way, shape, or form by the different strategies and the space type. So you can get, a simpler sequence of operations at the beginning of your project to be, and it used to be like the quicker discussion piece, but then as the project progresses along, it is a good practice to have a more detailed sequence of operations. It does take a lot of time to generate, but very worth it when you're discussing the design intent of a project. LDL has developed a sequence of operations learning guide alongside with a lot of guides. So if you can see the link below or go on our website for our resources, you can see our network lighting control series best practice guides. One lines are documents that are good for electrical contractors to communicate with facility professionals or the implementers as well. But they are documents that are going to be specific to a space, and they will highlight the hardware as well as what hardware is connected to other hardware by what protocol, whether it be by a specific wire, wireless, XYZ. But it's a good, more technical drawing to have a visual representation of what hardware is going to be in a space and how that hardware is connected to each other. Key for tenants, wall stations. It is just like sequence of operations. There's no it's a scope gray area where there's not one person that is being designated as it is your role to specifically develop a sequence of operation, or it is your role to ensure that wall stations get engraved. A lot of projects go unengraved or without meaningful engraving. Like you'll see buttons with scene 1, scene 2, scene 3, scene 4, and if there's anything that we can shout out from a mountaintop is like, hey, go against that practice. Ensure that someone is designated as a person to engrave wall stations and to ensure that they select the correct wall stations for the space, rather than have 5 of these one random square button wall stations in a space. It can be a lot better to have just one wall station with 5 buttons that are meaningfully engraved. So again, it is imperative to right size that spectrum of, simple and complex with few capabilities to a lot more capabilities. But again, that purposeful engraving is very important to implement. So when it comes to a project, ask who is going to be doing this to ensure that it is not missed. Programming commissioning tools, I've been referring to them a lot, and good to say that they are getting a lot simpler, especially when they're going into like mobile devices like mobile phones, tablets, as well as some computers. But the idea is, hey, even if they're not as simple or as seamless as they could be, commissioning tools are getting better, and they empower facility professionals to control their space without having to call the manufacturer's rep to come to site and then have to plug in their own devices to control the system. No, facility professionals are being now empowered to adjust settings, and some of those behind the front end settings of these systems. And that is a good trend, especially when it comes to operational efficiencies. And not all systems have configuration apps and again, mobile devices. Some have remotes, some only require computer programs. But the more that we can empower facility professionals and the less systems they have to work with, because lighting can again do many other features than just light a space, the better. Whether it comes to renovations, new construction, or retrofit, whatever the implementation is, it's always good to ask for training. This is, an example for new construction when you have Division 26 electrical documents, but regardless of the type of construction in your space, when there's going to be NLC systems implemented, always ask for your facility professionals to be trained in the system. Same deal about warranty and exploring warranty. You want to understand what type of warranty comes with your system, because it's all all electrical components are designed and, sorry, not on purpose, but they'll fail. So it is important to know what type of warranties a different system can provide to you. Ideally, when you're working with your different implementers, manufacturers, and territory reps, and you're shopping around solutions, always ask for the warranty. And good rule of thumb is like, hey, the warranty should not be longer than the manufacturer has been in business. End of the day, if you are looking for more resources on education tools or to have discussions, use Lighting Design Lab, use us. We, again, are providing all of these modules of education, and you can find them in our YouTube channel that's on our website as well. But plug into our classes. We're going to be doing a lot more classes next year as well. Check out our website. We have a good amount of resources, learning guides, and videos when it comes to NLC and LLC technologies and emerging trends. And as I mentioned, hey, we can do project-specific consults. If you want to have us be involved in your project, have a conversation, reach out to our email, reach out to us. Let's see if there's any last questions.
Do you see the one from Jeremy?
Jeremy, that is great. We actually, and I'll let Katie maybe go expand on it, but we have a webinar next week. Yes, next week
Yeah.
that talks about just that. Jeremy, you're asking about, hey, what's that guidance you would recommend from complexity to user friendliness on wall stations? And you know what? I will stop here. I will say it has been fun having you here, and I'm gonna let Katie take that question on herself.
Well, okay. Thank you everybody for attending. So we'll just do a little bit of closing up stuff. Jeremy asked about the friendliness of controls, and the Lighting Design Lab did do some polling around the user experience on controls wall stations. And so on the 15th, next Tuesday, John Wilson will be, and Eric, I think too, Strandberg, they're going to be talking about the results, the findings of that sort of there was a two-part study done by us. And you can't click on it right now, but when the slides get posted, you can click on that link and get registered, or find it on our website under the education tab. And we've got Armando's personal contact information. If you have a question for him, you can also just email to the Lighting Design Lab at seattle.gov email address, and anybody can pick that up and either ship it on over to Armando or answer your question. Also, there's a little screenshot there of what it looks like online, the education tab, and under the resources tab, you'll find the slide deck and a link to the recording of this presentation. Again, that's probably going to be two days or so before we can get that up. But a reminder that we are powered by Seattle City Light first and foremost, and 2020 we found support from BPA, Chelan County PUD, Tacoma Power, Idaho Power, and the Snohomish County PUD, so we thank them for their support. That is all, and another reminder, when I close the recording, a survey will pop up. It's not very many questions. It'll take you just a couple of minutes, and we would appreciate you filling that out. Thank you again, Armando. That was awesome, and hope to see some of you guys back next week for the findings webinar.
Awesome. Thank you, everybody. Signing out.